Hi guys! Today we are going to be talking about factoring out a monomial from a polynomial. This time it's going to be regarding the multivariate. So that means that we have more than one variable in our expression here. So just like in our last video, we are going to start out with finding our greatest common factor. We have to find our greatest common factor between both terms in our expression here. So let's start by, again, creating factor trees for both of our coefficients in each of our terms. We know that 6 and 4 go into 24. And breaking that down further, we know that 3 and 2 go into 24. As well as 2 and 2 going into 4. These are all numbers that cannot be factored down any further except for 1 and itself. We're going to do the same thing with 18. 2 and 9. Now we already said that 2 only goes into itself and 1. So I'm going to keep factoring 9 on the other side, 3 and 3. So remember, we like to stack our each terms, and we like to figure out what we can pull out of each of the terms. So I'm going to start with listing out the coefficients, factors, and remember, we're finding the pairs between things. Now, the only difference here between this video and our last video is that this time we have multivariates. Meaning, again, we have multiple variables thrown in there. So again, we are finding the GCF, and we do that by finding the matching things that both of our terms have here, okay? I know, just looking at our factors of our coefficients, they both have 2's, and they both have a 3, so we can pull those factors out of our coefficients here, okay? So I'm going to start by writing out a set of parentheses, and I know that my GCF, or my greatest common factor, is going to have a 2 and a 3, and remember, we're multiplying these together. Now let's think back to last video, where let's first just look at the u's. We do not need to look at any of our other variables just yet. Looking just at our u's, the first term here has 2 u's, and our second one has 7. So the maximum number of u's that we can pull out of this term here, of both terms, is 2. U to the second. Now that means that there's going to be no u's left over here, but we'll talk about that in a second. Moving over to our w's, we're going to treat this exactly the same. We're going to pick the smaller of the number because that is the most that we can pull out or factor out of each term. There's 4 w's in this term, but there are 8 in this one. So the most that we can pull out are 4. Okay, so we handled our w's, and now this first term here has x's, but I also know that this second term doesn't have any x's, so that means that that cannot be factored out because it's not in common between both of our terms. So what we see over here is the greatest common factor that we are removing out of both terms. We're going to leave inside that remainder. So in our first coefficient, we pulled out a 2 and a 3, and all we have left over are 2 2's, which means that is going to be a 4. Now we also pulled out 2 u's, and we pulled out 4 w's, so there are no more u's or w's left over after we factor those out. We've already factored them out in our greatest common factor. But what we do have left over are our x's. X to the third. We're going to bring down that same sign that was in our original expression, and we're again going to repeat adding in our remainder here. All we have remaining is this 3 in our second term. 3. Now here is where it's going to get tricky. We've pulled out 2 u's, okay? Thinking back to what we know about our exponents, we know that when we multiply 2 things together, we add those exponents, okay? So if I pull out 2 u's, that means that I have a remainder of 5 u's. And same idea with our w's. We pulled 4 out in that greatest common factor, which means that we have 4 w's left over. Now here, going back to our coefficient sitting in front, we know that we can multiply these together. All of this is being multiplied together. 2 times 3 is 6. So in summary, we factored this expression, we factored out the greatest common factor, and we know we can prove that we are correct by going ahead and distributing that greatest common factor back into our remainder. Let's prove it to ourselves. So going backwards, we know that 6 times 4, 24, u to the second times, there's no u's there, u to the second, times this w over to this first term. No other w's, so we're just going to leave it as w to the fourth. And there's already this x to the third there, multiplying it together. Plus, again, bringing down that side, we're again going to multiply in this greatest common factor into the second term. We're proving to ourselves that this factored form is the same thing as our original expression. So going back, 6 times 3 is 18. U to the second times u to the fifth, using that product rule for our exponents, is going to be u to the seventh. And then again, w times w, w to the eighth. So in summary, yes, we have proven that we factored out 24u to the second, w to the fourth, x to the third, plus 18u to the seventh, w to the eighth, to being what's in our box right here. Awesome job. Let's go ahead and do one more quick example. I'll go a little bit quicker. This time, we are going to have 24 v to the fifth, x to the eighth, minus 28 v to the third, x to the fifth, and y to the seventh. We always want to start by factoring our coefficients. That is always our step one, because we can do the rest of it pretty easily. I know that 2 and 12, 2 and 6, 2 and 3. We have successfully factored 24. I also know that going into 28, we have 2 and 14, also have 2 and 7, and I am done here because there is nothing besides 7 and 1 that multiply into 7. So again, writing down our factors of 24 and 28, and 28 here is, okay. So I see that both factors include a 2 and another 2. So I know that my coefficient is going to include a 2 and a 2. I'm going to leave a little bit of space so that I have room to include any other variables that we're able to factor out. And let's start looking at our v's first. Let's look at the v's. We have v to the fifth and v to the third. I see that the smallest number of v's that we have is 3. So that is the maximum number of v's that we can factor out. And let's just go ahead and let's go ahead by starting to write in the remainder over here in our parentheses. We still have a 2 and a 3 left over in our parentheses. 2 times 3 is 6. And I'm still going to have 2 v's left over. 2 v's left over. Now let's talk about our x's next. We now, on our second term, have 5 x's that we can pull out. That is the maximum number that we can pull out because over here we have 8. Okay? X to the 5th. And now there's again going to be a remainder of x to the 3rd because 8 minus 5 is 3. Okay? Again, going to bring that sign down from the original expression, and I'm going to include the remainder that we have left over in our second term. All we have left over is that 7. Now again, we already pulled out v to the 3rd. There's no v's remaining in that second term. We also already pulled out all the x's in that second term, but we do have y's left over, and we're just going to bring that down. We were not able to pull any y's out because this first term, no y's, okay? We multiply this coefficient together. 2 times 2 is 4. So we know that the greatest common factor between our original expression up here is going to be 4v to the 3rd times x to the 5th. This right here is a factor of those expressions. Okay? Box that off. And that is how we factor out monomials from our polynomial in a multivariate situation. I hope you guys have a fantastic day. I will talk to you guys later.